All right, we're looking at order of operations. Now, most of you already know this. We're going to cover it, but as this is an advanced class, we're going to be looking at some problems that are a little more challenging, a little bit longer, that you'll still have to follow your order of operations, your PEMDAS. Please excuse my dear Aunt Sally. They're just going to be longer problems. You have to be very careful with what you're doing. And that's a big part of this class, and really when we get into Chapter 2. We're almost done with Chapter 1 now. We only have a couple sections left. Chapter 2 is where it's going to make a big difference as far as your order of operations and being very meticulous and very slow and very deliberate in what you're doing. So, order of operations. Again, you've seen this before, but parentheses first, then exponents, multiplying and dividing from left to right. Doesn't matter which one comes first, as long as you go from left to right. And then adding and subtracting from left to right as well. So if you see subtraction first before adding from left to right, we do the subtraction first. So PEMDAS, but remember MD and AS there don't have to be in that order as long as you go from left to right. We'll look at some examples. So our first example here, simplifying the expression. Again, I want you to be following along. So if you want to pause it, if you think you got this, pause it, try it on your own, and then I'll do some with you. So for A, again, if you want to do a pause it, go and do that and try it. So for A, if I follow my PEMDAS, I'm reading from left to right. I'm not going to do 15 minus 2 first. I'm going to do 2 times 3 first, because multiplication comes before subtraction and addition. And I need you to rewrite the problem all over again. 3 times 2 is 6. But I need you to write the 15, the minus, the 6, the plus, and the 1. I do not want to see, and I'm going to put this in red, I don't want to see you do this and then right above it, this, and then right above that. I don't want to see it all in scattered places like that. I want to see it written below and rewritten every time. And you may not like that, but that's what you need to do. So 15 minus 6, I'm going to read from left to right, so I'm going to do that subtraction first. I'm going to get 9 plus 1. Again, I'm going to rewrite that. And 9 plus 1 is 10. So I want to see that triangle. I don't want to see that triangle shape. You do not need to rewrite the triangle or draw those lines in there to make the triangle. If you want to, go for it. But I do need to see that triangle shape come out of this problem. I need you to rewrite every step. So for B, same idea. I'm going to read from left to right. And I'm going to do not 12 minus 3. I'm going to do the exponent first. There are no parentheses. So I do the exponent. 3 squared is not 6. 3 squared is 9. 3 times 3. We got 12 minus 9 plus 10 divided by 2. I'm going to rewrite all that. Again, I'm reading from left to right, and I see that there's division. And so I need to do division before I do any adding or subtracting. 10 divided by 2 is going to give me 5. So 12 minus 9 plus 5. Again, reading from left to right, I'm going to do that subtraction first. 12 minus 9, I'm going to get 3. Plus 5, which gives me a final solution of 8. You'll notice it did not take me long to do that, and I had to talk through it as well. And so it shouldn't take you too long to write those steps. That extra couple seconds it takes you to rewrite it is not going to kill you, and I need you to write those steps down so you can communicate to me what you're doing. And if you get the final answer wrong, but you make a mistake right away, I can look at that and give you partial points. I don't know why it does that. Okay, let's try this again. Again, simplifying, pause it, try this on your own. I will say that it's not, right here, it's not number 5.4, it is 5.4. And so that is the 5.4. Go ahead and pause it, try it on your own. All right, I'm going to assume you tried it on your own. The first one right here, if I look at this first one, I'm going to read from left to right. There's no parentheses, there's no exponents. 8 divided by a half. 8 divided by a half is not 4. Remember, if you're dividing with fractions, we need to take the reciprocal of the second fraction, and we need to multiply. And so 8 times 2 is going to give me 16 times 3. So if you made a mistake there, you got to be careful with those fractions. Don't just go. You need to really think about this and be meticulous. They're going to be difficult. 16 times 3 then, a little mental math, 30, 48, I believe. And that'll be my final answer. Now, my work is going to get a little bit scrambled here, so I'm going to circle some answers so we can follow it. For the next one, again, we've got no parentheses, but we do have an exponent. 3 squared is 9. 5.4 minus 9 plus 6.2. So I'm going to do my subtraction first. And since it's a minus sign, I'm going to do keep, change, change. So I've got negative 5.4, 5.4 plus negative 9. They have different signs. I find the difference. And I'm going to get, let me double check that. Well, I'm going to put it up here just because it's been a long day and my brain isn't quite there, so I want to make sure I get the right answer. So I'm going to do a little bit of scratch work here. 3.6, negative 3.6 plus 6.2. Again, I've got different signs, so I'm going to find the difference. And if I do my scratch work, I've got 6.2 minus 3.6. I'm going to find the difference. And I'm going to get 2.6, and that'll be positive. I've got my final answer. Don't be afraid to do a little bit of scratch work. If you can't do it in your head, that's fine. Some days I can do it in my head great. Some days I go, nah, I don't trust myself. And I'm going to try and do a little bit of scratch work to make sure I get the right answer. All I need to see in terms of work shown is what I just circled here in red. The other stuff is great to write down, and you should write it down if you need to. But we want to try and keep things as organized as possible to get that final answer of 6.2, or excuse me, 2.6. Last one then here. I have parentheses. In fact, I've got parentheses and brackets. I've got all sorts of stuff. So there are multiple ways to look at grouping things. Parentheses are a great way to group things, and you'll see that the most. But eventually, if you start getting lots of parentheses, it can be really hard to keep track of things. And so you might see these brackets as well. That's just another form of parenthesis, of grouping, and it acts the same as parentheses. It just looks a little bit different. And we're going to talk about a couple different forms of grouping in a little bit. But if I look inside the brackets, I see a negative 2 times, and then I have another set of parentheses. So I'm going to have to do those parentheses first. So inside the parentheses then, I've got 4 plus 1. 5. So negative 2, 5, brackets, I've still got this negative 20 divided over here. All right, now I've still got parentheses. I've got these brackets anyway, so parentheses. And inside those brackets, negative 2 times 5, negative 10. And then negative 20 divided by negative 10, a positive 2. So if you got those wrong, check what you did, fix it, and we're going to move on and we're going to look at some more examples. The steps aren't, each individual step you've learned before. Now it's putting all these steps together and being very, very careful about which steps we're doing first. I mentioned that there's different ways of grouping things. So fraction bars are another way of grouping things. Radical symbols, which is not like rad man, but a different type of symbol, which we'll talk about. Absolute value bars are all ways of grouping things. So if you see a giant fraction like this, got a big numerator, a big denominator, what you really want to be thinking, and I'm going to have you do this on your page there, is that the numerator and the denominator are in parentheses. We don't draw them there, but they're there. It's a group. We have to do everything in the numerator first and everything in the denominator first. We can't mix and match. We have to do everything in the numerator first before we can do anything else. Everything in the denominator first as well. Now this is going to get to be a lot of writing. And so when you're getting to your assignments, don't just number down the side of the page, 1, 2, 3, 4. This problem alone is going to take up at least 6 or 8 lines. It's going to take a lot of space on your page. And so once you get to a problem, just stop, do the problem first. They're going to take up a lot of space on your page. I'm sure you're excited about that. All right, let's take a look. So I'll stretch it out here. We've got a long one. So looking at the top, we've got those parentheses, but really there's multiplication right here, and there's addition right there. So that's what we've got on top. On the bottom, we've got exponents, and we've got subtraction. I know from PEMDAS we got to do exponents first. So I'm going to rewrite the top. I'm going to rewrite it 2, negative 4, plus 22, all over 16 minus 9. So I've done my exponents. Now I'm going to look, and every letter in PEMDAS deserves to have its own step. So I've done my e, done my exponents. Now I need to do multiplication or division. I know on the numerator there's multiplication, so I'm going to rewrite it. I've got 2 times negative 4, that's negative 8, plus 22, all over 16 minus 9. Okay. Next I do any adding or subtracting, and I've got adding on top. So negative 8 plus 22, again, different signs. So I find the difference, and that one, that one I'm going to do in my head. I'm going to get that we get what, 16 out of that. Is that right? No. See, my brain is not functioning today. We're going to get 14. 14 from that, and so we've got 14, and we've got 16 minus 9, and again, I don't know why my brain is just dying on me. Must be 7, I would hope. Right? Yeah, 7. Okay. 16 minus 9, 7. And then we've got our final step. We've got 14 sevenths. Now, don't circle it. Sorry, erase it if you circled it over. That's not the final answer. 14 sevenths is a fraction. However, remember, a fraction bar is the same as division. Division is the same as a fraction. So 14 sevenths, that's 14 divided by 7, which is 2. 2 is the final answer. And if you really want to see how that works, remember that if you have this fraction, 14 sevenths, you can reduce it. Well, if I reduce this by 7, I'm going to get 2 over 1, which is just 2. And so you could reduce it down if you really wanted to, but that purple, that's a lot more steps. We've done a lot already. And so I want to do as little as I have to get the right answer. So I'm not going to reduce the fraction. I'm just going to remember that fractions are division. And 14 divided by 7 is 2. That's a lot of work. Look at all that work we did. A lot of steps. But it's manageable if you go slow and you do every step and are very careful. Try these 3. Pause it, try these 3. All right, here we go. Deep breath. We got a lot to do here. And so this first one, I'm going to move this over a little bit to give myself some room. This first one I'll do in purple. So we look at both the top and the bottom. Remember, it's like having parentheses. So we have to do the numerator and the denominator separately. I see no exponents, so I'm going to move on to multiplication. So 5 plus negative 16 all over negative 2 minus 3. Okay, so I've got addition. 5 plus negative 16, they have different signs, so I find the difference. And I'm going to get negative 9 over negative 2 minus 3. And then my last step, well, almost last step, negative 2 minus 3, if I do my keep, change, I've got negative 2 plus negative 3, that's negative 5. And negative 9 divided by negative 5, we can't get a nice whole number out of that, right? We can't get a nice natural number, a nice integer out of that. But we can't leave it as a fraction. We can reduce this. We can simplify it. Negative 9 divided by negative 5, well, a negative divided by a negative is positive. And I know I can rewrite that as 1 and 4/5. That's simplified. That's reduced. We do need to simplify, and we do need to reduce. You will always need to reduce. You always, always, always need to reduce your fractions. And so we've got 1 and 4/5 from that one. Sorry, I'll leave that down there. You can pause it if you need to keep looking. The next one, these are absolute value bars. Absolute value bars are another way of grouping. So it's like parentheses. So absolute value is not part of PEMDAS, but since it's a way of grouping, we consider it parentheses. So I do my parentheses first. 4 minus 7, I got to do my keep, change. And so if I do 4 plus negative 7, different signs, so I find the difference. Negative, because 7 is bigger than 4, 3. Absolute value bars are still there. Squared is still there. Divided is still there. Negative 3 is still there. If I'm going too slow or too fast for you, pause it, catch up, and we'll keep going. Now those absolute value bars, I got to do the absolute value. Remember, absolute value is the distance from 0. How far from 0 is negative 3? Well, negative 3 is 3 away from 0. So the absolute value is 3. It's always positive. It's not the opposite. But absolute value is always positive. And I'm just going to put parentheses there. Okay, so 3 squared, I'm going to move this down. We've got exponents. We've done our parentheses. We did that absolute value. Exponents. 3 squared, we've done a bunch of these now, 9 divided by negative 3. And 9 divided by negative 3, I'm going to get negative 3. Last one. Last one. Square roots. Now I mentioned radical signs. A radical sign is like square root. I'm going to create a new page here. You don't have to write this down. I'm just going to talk quick. A square root is the opposite of squared. So opposite of x squared, square root of x. But we could keep going. X cubed is what's called the cubed root of x. If you wanted to say, let's go with 8. 8. If I wanted to know some number cubed, some number x cubed equals 8. Well, to do that, and your calculators will do this, you would take the cubed root of 8. You would take the cubed root of both sides. X would be left over here, and 2 would actually be left. 2 times 2 times 2 is 8. So you can take the cubed root. That's a radical sign. I mean, I know it's really cool and awesome and radical, but it's called a radical sign. A fifth power, you'd have the fifth root. And those are radical signs. So that's what we mean when we talk about radical signs. We will really only be looking at square roots, but that's a radical sign. So we've got a radical sign. It's like parentheses. In fact, some calculators even insert parentheses in there. Well, square root of 50, I have no idea what that is. And really, we can't take the square root of 50 minus 1 yet because we haven't done those parentheses. 50 minus 1 in those parentheses first is 49. That looks a little bit better. I can take the square root of 49. So those if you have more than one number underneath the radical sign, we need to subtract first. So I take the square root of 49. Square root of 49 is plus or minus 7. We're not out of the loop on that. We do need to use that plus or minus still, which confuses things a little bit. We've got that. Well, how do we deal with that plus or minus in there? Think about this as one number. You've essentially got two problems that you're dealing with. And I'm going to do it over on the side here. However, you wouldn't need to show it this way every time. And I'll show you the shortcut. But really what you're looking at, let me put it in a little box so we remember that it's separate, is 3 times positive 7, or plus or minus, that's the symbol, 3 times negative 7. 3 times 7 is 21. 3 times negative 7 is negative 21, which means we really end up with plus or minus 21. And so in our problem in red here, that plus or minus sign essentially just stays out. And 3 times 7, we get plus or minus 21. That works with multiplication. Addition is a little bit different. But so when you have a radical sign, if there's more than one number underneath the radical sign, like 50 minus 1, we subtract first. It's like parentheses. Then you can take the square roots, and that plus or minus is still part of the 7. But times 3, we get plus or minus 21. Oh, and I think this is the last one. Yes, last one here. So give this a try, and then we'll do it together. Okay, we got a substitution. We know what x is, so we're going to have to substitute. X is 6. So I got 6 times 2 squared in parentheses divided by 2 plus 6 parentheses. Do my parentheses first. I've got an exponent in one of them. So 6 times 4 divided by 2 plus 6. I do multiplication. 6 times 4 is 24 divided by 2 plus 6. Now I can't do 24 divided by anything yet. So I can't do my division yet. I have to get rid of those other parentheses. So 24 divided by 8, we're going to get 3. And again, you'll notice that I'm keeping it with that triangle method. So I want you to keep those, keep that method of doing it, the way to show that work in mind as you're doing these problems. Okay, that's it. And good luck on the pretest.